Good morning, everyone. It looks like we're going to have another nice day today. We've got a pretty short and simple activity this morning, but it's going to help us explore some really important concepts about our solar system. So I can see Vivian's all set. She's got lots of materials. What you need for this activity is some different sizes of balls. So I stole this nice stuffed soccer ball from my dog this morning. I have a golf ball and a tennis ball. If you have different ones, that's fine. It's just important that they're different sizes. I love that Vivian has an earth because we're going to be thinking about this in relation to Earth and the moon and the sun. So that's awesome. I will give you all a second to collect your balls if you haven't already. I think most of you have joined us, so I'm going to ask Peter to do a very abbreviated reminder of Zoom etiquette. Awesome, thank you all. I'm so impressed with everyone's collections of spheres here. So we are going to begin by thinking about the different sizes. So everybody has balls of different sizes, right? When I hold mine to the screen, you can see there's a different size. Can anyone think of a way to change your perspective to make these balls appear to be the same size? So let's think about that. Have you ever looked at a building or a tree from far away? Has anyone done that? Does it look smaller or larger than when you're up close, when you look from far away? So Vivian's miming, it looks smaller, right? Sometimes you get pictures of people holding up buildings like the Empire State Building in their hand, or the Eiffel Tower, and that's because of perspective. They're very close to the camera, but the building is far away, so it looks small. So we're going to use that same principle to explore the apparent size of our objects. So I have a golf ball and a tennis ball right now, and I'm going to move these objects. I'm going to move my larger one away from the camera until it appears to be about the same size as the golf ball. Do those look to be a similar size now? And then what happens if I move my golf ball in front of my tennis ball? Can you see the tennis ball? No. So some of you are working with much bigger balls and you have bigger size differences. So I'm going to challenge you now. Find your biggest ball. You can put it on a table, or if you're working with someone else like Trey and Corinne, one of you could hold the big ball and one of you could hold the small ball. And you're going to move apart from each other until your balls look to be about the same size. So I see Jacob is working on that. You, Trey and Corinne, have a really big challenge. I think you're going to have to go really far apart. So Vivian, it's important when you're doing this, they need to be different distances from you. So not moving them away like this, because then you can still see that they're different sizes, right? You want to move one backwards and forwards. So the easiest way to do that is going to be to put your bigger ball on a table or rest it somewhere, and then you can get up with that smaller ball and actually move away until it looks to you like they're the same size. And a good test is to put your smaller ball in front of the bigger ball and see if it eclipses that. Trey and Corinne, I think you all are going to need to spread out even more to get this effect. Jacob, have you been able to eclipse the big ball with the small ball?
I'm Jerome, but...
Sorry, Jerome.
I'm using a light so I can make a real eclipse right now.
Oh, cool. So you've got a light shining and you're moving that smaller ball between the big ball and the light. So I'm going to go ahead. Jerome mentioned an eclipse. Let's talk about that. Oh, are you able to enable me to screen share?
Yeah, let me figure out how to do that.
Does anyone know what a solar eclipse is? Jerome?
I think we unfortunately can't do that once the meeting.
Solar eclipse is when the moon is in front of the sun and the earth is behind the moon.
Yes.
Kind of like this.
Right. So in a solar eclipse, you have your really big sun and you have your earth and you have your moon, which is much, much smaller. But because the moon is much closer to earth than the sun, it's able to eclipse the sun. So the sun is 400 times the size of the moon, but because of what we just practiced and saw with apparent size, because they look to us to be the same size because the sun is much farther away, we're able to eclipse the sun with the moon, even though the sun is bigger.
Emily,
now,
I think you should be able to screen share now.
Okay, cool.
I think that should work.
I'm gonna try to show you all an image of what I am talking about. Can you see this screen now? Okay. So we get a nice of a solar eclipse. You have your big, big ball of the sun. You have your smaller Earth, and you have the moon, which you can see is much closer to Earth than the sun. It's actually about 400 times closer. And that makes up for the difference in size. So that at certain times, when everything lines up perfectly, the moon is in between the sun and the earth, and it casts a shadow. So it looks to us like the sun has been blotted out. This is a total solar eclipse. These don't happen all that often, maybe about every 6 months, but usually they happen and the shadow falls out in the ocean so that we don't get to see it. But every so often that shadow falls onto a continent where people are living and you can see the total solar eclipse. You have to remember that all of these objects are moving around each other, right? So the earth is moving around the sun, the moon is moving around the earth, and everything has to line up perfectly to get that eclipse.
Emily, it looks like Trey and Corinne are asking how does
so your challenge is to
sorry
how does it cast the shadow? Yeah, good question, Trey. So Jerome, you've got a light going on. Can you put your ball in front of that light for us? Yeah, so we've done a bunch of activities with shadows, and unfortunately I don't have a flashlight with me, but if you have a flashlight, try shining it on your ball and see what happens. Anytime you move an object between a light source and the ground, it's going to cast a shadow on the ground. Because you're blocking the light from that specific area. Just like you guys did with Peter the other day when you were tracing shadows, right? Has everyone been able to get their different sized balls to be the same apparent size? Some of you probably had to move pretty far across the room, right? I picked some that were already not too dissimilar in size so that I could do it on camera. But if I were working with these two, I would need to be much farther apart for them to appear the same size. Just like with this. Does anyone have questions or thoughts about this? Trey and Corinne, I hope you'll play a little bit with shadows and things. See if you can add a light source into the equation. Oh, Vivian, are you using the Q-tip end as a ball? So that's really small. Maybe you're just cleaning off your materials. That's good too. I would encourage you all sometime today and this evening to go out. Oh, awesome, Trey. That's perfect. I'm glad you got to experiment with that shadow, right? So look sometime over the course of the day and the evening at the sun and moon. And you'll notice that to us, they do look to be about the same size, even though scientists know from satellites that they are really, really different sizes, that the sun is 400 times larger than the moon. Don't look directly at the sun, but especially while it's setting, it's a good time to get a good picture of how big that is. And next time there's a full moon, you can go out and look and compare the sizes, the apparent sizes. All right. Awesome. Thank you all for joining me and making this little solar system model today and talking about eclipses. I was doing some research this morning to figure out when the next total solar eclipse will be. I think there's one later this month, but it won't be visible in the northern hemisphere. So we might have to wait a few years before we get another full solar eclipse visible from the United States. All right. Oh, thank you, Trey. Good reminder. So tomorrow is Wednesday. That's our animal day. We're going to be exploring some animal superpowers. So we will be talking about regeneration, about different animals that can regrow parts of their bodies. And we'll be doing that while I'm visiting with the animals at the Science Center. So we'll get to meet some of the animals in our collection that have this really remarkable ability to grow back limbs or tails or even parts of their brains. So that's what we'll be doing. And we will be joined by a guest scientist from Cornell who studies this. Sound good? You don't need any materials, just your brains and questions.
How did that happen?
Right.
I think it's not
Uh-oh, we've got a deflated planet over there. Luckily, that does not usually happen to our moons or planets, but it can happen to beach balls. All right, looking good, Jerome. I hope you'll show Jacob what we were working on. I'm gonna go ahead and say goodbye, and I hope to see you all tomorrow. And I hope that you'll take a little bit of time to think about apparent size today and check out the moon and the sun.
Bye, everyone.
Bye.